guys. Okay, so this first video is strictly on your notes from your notebook. Okay, strictly on your notes from your notebook. So the first thing I want to go over is something you really need to know. And I would, if you write nothing else down that I tell you today, if you write nothing else down that I tell you, you need to write this down. Okay, this is what's important. So when we're doing these, if we have x is greater than something, x is greater, you're going to have an open circle with a line that goes that way. Okay? If we have x or any variable is less than something, like so, we're going to have an open circle less left, great right. Okay, less left, great right. X is greater than or equal to is a closed circle going to the right. X is less than or equal to something is a closed circle going to the left. This is probably one of the most important things you can take out of this. The thing to remember is x must always, always, always be on the left-hand side of your inequality for this to be true. Okay, you can always flip it like we did with our equations when our equal sign, when things didn't look right. You can do the exact same thing with this, okay? So, this is important. The open circles and the closed circles. I've put it on your PowerPoint I did for you. I'm talking about it here. It's in your notes, and it's in your second set of notes I'm giving you all. It's important, okay? I don't know how else to say that. It's very, very important for you all to do this. Take nothing else away, take this away. Okay, make sure you have that written down. Now, vocab, solution of an inequality. Any value of the variable that makes the inequality true. Okay, so when we're talking about a solution of an inequality, it can be a whole set of numbers. And the difference here is when the circle is open, that means that number is not included. And when the circle is closed, it means the number is included, okay? So that's the difference. Number is not included, the number is included. That's why we had equal to, okay? Number included, number not included. And so we have the info to know. Steps to graphing a solution. You solve the inequality like an equation. You decide what your inequality is. So you see above. Is it greater than, less than, greater than or equal to, less than or equal to? Then you place a circle over the value of your answer and a shade in if needed. And then you draw a line in the direction of your solution. And that's the big thing about your notes. Your notes are pretty simple. Now, the other parts of your notes are things that if we were in class, I would pass out to you and you would get them. But we're not in school, we're not in class, I can't pass them out to you. These are just pieces of information you can have, okay? They're there for you. They're there for you to look at. I just want you to know they're there. You do not have to print these notes out unless you just feel an overwhelming need to. Okay, that's what these notes are for. They're there to help you. So, close that up. That's all we're doing with those today. Now, this next part. It says, which of the following numbers are a solution? Because we're going to look at these practice problems on your notes. Okay, we're just going to pick and choose a few to do. And then that's all we're going to do with this one. Okay, and it's going to be all for our notes today. So let's look. It says, which of the following numbers are a solution to x is greater than 0? So let's talk about it. What numbers are greater than 0? Is -5 greater than 0? No, -5 is not greater than 0, so that's not a solution. 0 and 3/100, is that greater than 0? Yes, it's greater than 0. So you're going to write that down on the line. 0 and 3/100. Is -1 greater than or equal to 0? No. So don't write that one down. 0. Is 0 greater than or equal to 0? Yes. So write that one down. 1. Is 1 greater than or equal to 0? Yes. So write that one down. As actually 1.5. I'm sorry. 1.5. Is that greater than or equal to 0? Negative 6. Is negative 6 greater than or equal to 0? No. That's less than 0. And 1/2. Is that greater than or equal to 0? It's greater than. It's greater than. So write 1/2 down. So on your line, you should have 0 and 3/100, 0, 1 and 5/10, 1/2. Okay, graph each inequality. So here we go. We're going to graph each inequality. Our first one is t is less than or equal to 8. T is less than or equal to 8. Okay? So we have a line. So t is less than or equal to 8. I'm just going to make some numbers on my line. 10, 9, 8, 7, 6, 5, 4. So the number we're dealing with is 8. And it's less than or equal to. So I have open or closed circle. It's less than or equal to. So my circle is closed, which means 8 is included. So I'm putting a number, a closed circle at 8. And it says less than or equal to. So it's going to go to the left. And if you notice, when this is this way, my inequality points me in the direction I need to go. It tells me I need to go left. So here we go. I'm going left. T is less than or equal to 8. Let's look at 8, negative 7 is less than h. Now I want to look at this one because here's the problem. Is our number is in front of our variable. But I can switch this. And when I switch this, I want to keep my alligator eating my letter. So h is greater than negative 7. H is greater than negative 7. Okay? Is saying the exact same thing as negative 7 is less than h. So I'm going to make my number line. Negative 8, negative 7, negative 6, negative 5, negative 4. Why did I count that way? Counted backwards, kind of, didn't I? Because remember, when we start at 0 and we're going negatives, we still start at 1 and count our way down. Okay, so that's something really important to remember as well. Okay, so negative 7. There's no line, so we're going to use an open circle. And h is greater, so it goes to the right. So there we go. It's not too difficult. Let's look at number 11. I'm going to look at number 11. Number 11 says negative 4.5 is greater than x. This is another one of those I have to flip around. Okay? So it's going to be x is less than negative 4.5. Made my number line is kind of going downhill, but that's okay. Okay? We all mess up. We all make mistakes, right? So, x is less than. So, if x is less than negative 4.5, my line is going to go to the left, which means I'm going to have, I'm going to go 6, 5, negative 6. Uh-oh. I'm counting wrong. 3, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Negative 4.5. Will negative 4.5 be between 3 and 4 or between 4 and 5? It's going to be between 4 and 5. So this is negative 4.5. There's no line, so it's here. It's negative 4.5. It's less than, so my line is coming to the left. It's right here. And that's how that one would look. I want you to see how it looks with negative numbers because it's a little different, okay? Now, let's look down at the next ones. Those next ones are really hard to read because, write this one up underneath there, because the circles are hard to read if they're open or closed. So I'm going to kind of, let's see if I can pull this up, but probably not. Let's look at number 12. And number 12, we're going to say that circle is open. Try to pull this up a little bit closer for you to see. There it is. Number 12 is an open circle on the 6, and it's going towards the bigger numbers. So if you look at number 12, there it is. Okay, so it just wants us to write down what the inequality would be. So we always start out with x first. And since it's going to the right, it's greater than. So x is greater than. And since it's an open circle, there's no line. And it's on the 6. And that's all you have to do. Number 13. Hold it up. Remember, we always start with x. Number 13 is a closed circle. So number 13 is a closed circle. And it's on the negative 3. It's number 13. Since it's a closed circle, it's on negative 3. And it was going to the left. So left means less than. And it was a closed circle. Okay, I want you to try 14 and 15 on your own, and then you can put those into our discussion, okay? 14 and 15, and put them into our discussion. Now it says, write a graph and the inequality to represent this situation. A child must be at least 48 inches tall to ride a roller coaster. A child must be at least 48 inches tall to ride a roller coaster. So X, they have to be at least 48 inches tall. So what does that mean? They have to be at least 48 inches tall. That means X, okay, the child is going to be X, so this is the child, okay, has to be at least, we have 48 inches, okay, has to be 48 inches tall or taller, okay, is what that means. So then they ask us a question. It says, can a child who is 46 inches tall ride the roller coaster? So if they're 46 inches tall, can they ride the roller coaster? No, because they're not 48 inches tall. Okay? Very good. That's the end of these notes for today. So the next thing we're going to be picking up on is I'll do a new video, and I'll pick up on the next set of notes that go with this. And good luck.